So this lesson is going to go over slope-intercept form and how to find and write slope-intercept form giving different pieces of information. So this is the same table we started with in our lesson on point slope form. So I found the change in x and the change in y to help me with the slope or the common difference. And I had the first term, which gave me this explicit form. So what we're going to do from here is actually derive slope-intercept form using that information from the table that we just had. So 1, 3 was our first value, 5 was our slope or our common difference. So our first output goes first plus our common difference times x minus our first input. So what we're going to do here first is actually distribute the 5. So I'm going to do 5 times x and 5 times -1, which is going to give me y equals 3 plus 5x minus 5. And then I'm going to combine like terms, and that's going to simplify to my slope-intercept form of y equals 5x minus 2. So 5 is our slope, and -2 is the value of our y-intercept. That is the coordinate where, or the value where, we're crossing our y-intercept. So for any given y-intercept with a slope, what I'm going to use is this slope value and the y value of our y-intercept, because the x value for our y-intercept is always going to be 0, because 0 is the x value that puts us on that y-axis. So this should look familiar. This is probably something that you learned in middle school math, but y equals mx plus b is our slope-intercept form. And so this is what we're going to use today. So write an equation in slope-intercept form of the line with a slope of 4 and a y-intercept of 5. So I know the slope, and I know the y-intercept. So those two things are going to go directly into the m and b positions in our equation. And that's it. For this type of problem, that's all we got to do. Now sometimes they will give us a graph where we have to find the equation of slope-intercept form from a graph. The first thing I'm going to do is find my y-intercept. Well, here it's a whole number tick mark, so that I'm okay to use that. If for some reason I did not cross the x-axis, or excuse me, the y-axis at a whole number, I would have to use a different point. So if it crossed at like 6.2 or 6.3 or somewhere up here that we're not really sure, I'm going to have to use a different point. And I'll show you how to do that in the next example. So I know my y-intercept. Then I'm going to look at the change between these 2 points to find the slope. The first thing I'm going to do is look at the vertical change, or the y change, or the rise. Because it's going down, it has to be a negative value. And then I'm going to the right one. Now, anytime my graph is decreasing or going down, as I move left to right, the slope has to be negative. So here our slope is -2 divided by 1, which simplifies to -2. And then I can go straight to my slope-intercept form from here with -2 going in for M and 6 going in for B. Now this last example is an example of what I might do if I know the slope, or I'm given a graph where I can find the slope, but I have another point that's not the y-intercept. So if I have a graph that does not have a whole number y-intercept value, this is the example I would follow. So I'm given a point and I'm given a slope, and I'm going to start writing this as if we were writing an explicit formula equation. I have my common difference because that's the same thing as the slope. I have my first input from my coordinate as well as my first output from my coordinate. And I'm going to put those three things directly into my explicit formula. Now it's plus 3 here because it was x minus negative 3. From here, I'm going to distribute this negative 2/3. I have to multiply it by x, and I have to multiply it by 3. So the first thing I'm going to look at is this negative 2/3 times 3. And I have it set up for you here. I have negative 2/3 times, technically, this 3 is 3 over 1. And since I'm multiplying two fractions, I'm going to multiply numerators and I'm going to multiply denominators. So I'll have negative 2 times 3 and 3 times 1, which will simplify to negative 6/3 or negative 2. So this negative 2 is going to be what I get when I multiply negative 2/3 times 3. And then when I multiply negative 2/3 times x, I get negative 2/3 x. So this would be what my distributed equation looks like. The next thing I need to do is combine these two like terms of 7 and negative 2.
Good morning, Pender Early College. This is Ms. Makula with your morning announcement.
Sorry, I didn't realize we were going to do announcements. And so this is my simplified slope-intercept form equation.